Assalamualaikum and hello everyone. My name is Eza and I will present you the type of catalyst used in nitric acid production and its properties. In nitric acid production, the type of catalyst used is platinum based. It is a catalytic metal and metal oxide, and the elements of rhodiums, palladiums and platinum are extensively used in many industries due to their extremely high activity and selectivity. Platinum-based catalysts have been used in a century, commercially since 1990. Within those years of industrial revolutions, enhancements of platinum-based catalysts with rhodiums are applied to avoid platinum losses, and later, palladium-based catchment or categories were added to further reduce the losses of platinums and rhodiums. Next to the metal gauze image is a picture of a rhodium and platinum gauzes being installed in an ammonia oxidation plant. Normally, a number of gauzes are used in the form of a pad. Properties and characteristics of platinum, rhodiums and palladiums catalysts part 1. The structure of catalysts. There are 3 designs of catalyst gauze experimented for its efficiency in nitric acid productions. It is in the structure of heterogeneous catalyst, where the catalyst gauze arranged in the form of a pad. First is in the form of woven gauze, which is arranged in a rectangle grid and in 2 dimensions. Second is in a form of well-knitted gauze, which is weaved in open circle. It is also stretchable. Lastly is in a form of wrapped knitted gauze, which is weaved in a closed circle. The roundly crossed wire, which if broken, the wire will still tie around the broken. Next, we will proceed to the next slide, part 2. Because of the different temperature of the oxidation formation, it is thought that the platinum has higher excellence catalytic activity. The volatilization temperature for platinum oxide is 380 to 400 degrees Celsius. For palladium oxide is 877 degrees Celsius. For rhodium oxide is 1113 to 1127 degrees Celsius. Generally, this oxide could inhibit a catalytic reactions, while platinum always presents a new surface after the platinum oxide is volatilized. This graph shows the oxidation rate analysis in comparison with the same unit of 180 dp rate. The blue line is the platinums, rhodiums and palladiums alloy group gauze, which depicted the platinums, rhodiums and palladiums catalyst has higher conversion value, which explain the higher yield of activity and selectivity in the synthesis of nitric acids. The red line shows the conversion trend lines of rhodiums and platinums group gauze, which is lower than the platinums, rhodiums and palladiums catalyst. That's all from me. Now we will proceed to the next part presented by my teammates.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rabiatul Adawi binti Hafizan. I'm from Group 5 and I would like to present about production of nitric acid through oxidation by using platinum, rhodium, palladium as catalyst. Nitric acid, which is HNO3, is a strong inorganic acid and colorless liquid that produced in a large volume. Nitric acid is manufactured from ammonia and it is important industrial chemical for fertilizer production. From the pie chart, we can see the percentage utilization of nitric acid. So far, the main use of nitric acid, which is 80%, is dominantly by fertilizer production, and 10% is used for other. Some nitric acid is used to make intermediate in polymer industry, and it is also important in manufacture of hexadionic acid, which is adipic acid, to make polyamide, which is 3%. Other than that, nitric acid also has been used in TDI, which is stand for toluene diisocyanate or methyl diisocyanate, to make polyurethane, and it is also used as 3%. Lastly, nitrobenzene is used to make aniline, which is a key reagent to making it a dye. The current production rate of nitric acid is called Oswald process. Oswald process was and still a very important process because it is an easiest way to create nitric acid, which only 2 steps. The first step is oxidation of ammonia, and the second step is absorption of the resulting nitrogen oxide. Oswald process, which is created by Wilhelm in 1902, is still being used today because it is reliable and the easiest way to create nitric acid for the high demand it is needed for.
This is January Abdul. I'm from Group 5, and now I will explain about the chemical or mechanisms involved in the reaction in the reactor. And so the PT-PRH-PD alloy has been proven to increase the production of ammonia oxide in the nitric acid company. And in a journal published by a researcher named Ning Yuan Tao, in the journal, the researcher states that by adding the palladium component in the PT-RH-PD alloy or catalyst, it has been proven to decrease the weight loss and also the amount of platinum loss, which means that this particular type of catalyst will not degrade as easily as other catalysts would for the same reaction. And now we shall move on to the chemical reaction itself. As you can see here, the first reaction is shown is the typical reaction that is used to produce nitric acid, and thus the nitrogen oxide is produced in this reaction is then bubbled with hydrogen peroxide in order to increase the acid yield, which is shown in the second reaction. Commercially, nitric acid must be between 52% and 68%. That is the benchmark that most companies would follow and would always vary between each company. And so the chemical process involved in producing nitric acid is called the Oswald process, and in this process, ammonia is oxidized with nitric oxide in the presence of either platinum or rhodium, in theory palladium, at a temperature of about 500 Kelvin at a pressure of 9 atm. As you can see, the reaction that I talked about previously is shown here. And so in the above reaction, the nitric oxide that is produced is then reoxidized again with the oxygen in the air to produce nitrogen dioxide, and that nitrogen dioxide is then absorbed into water to produce nitric acid. And so finally, this is the nitric acid that has been produced. And so this nitric acid that has been produced will be then reoxidized to continually produce more nitric acid. And alternatively, if the last step is carried out in air, the following reaction will occur, which is the one shown here. And so the nitric acid produced will always be in aqueous form, and this can be further increased in percentage of purity of nitric acid by the process of distillation up to 68%, and also the concentration can be furthered up to 98% in the process called dehydration along with concentrated sulfuric acid. And that is all from me. Thank you.
Sustainable development element can be seen in three aspects, which is social, environmental, and economical. For environmental, these productions have proper management in natural resources, and it leads to habitat restorations and preservations. In socials, it has improved in human society and concept of equality for certain and future generations. For the economical, these productions have long-term benefit rather than short-term benefit, and it's more focused on environmental and social aspect.
Assalamualaikum, my name is Muhammad Akmal. There are some modifications that have been made in order to improve the production in nitric acid over the chosen catalyst. In the current operation, the parameter used does not improve the catalyst efficiency. Generally, in the production of nitric acid, platinum, rhodium, palladium alloy gas will form platinum dioxide and will be located on the surface of the catalyst. This will lead to the loss of platinum in the amount of 0.05 to 0.3 gram per ton of production. Hence, to recover the loss, catchment gas of palladium-based alloy was installed beneath the catalyst gas. However, it reduced the catalysis effect of platinum and it reduced the platinum utilization. Therefore, a new operation modification has been made and the parameter used has been adjusted. 13 sheets of platinum, rhodium, palladium alloy is installed in the production of nitric acid, and the structure gas of warp nitro gas is applied as it is the current best structure of gas can be used. Let's proceed to the installation of platinum, rhodium, palladium alloy gas. For the installation of platinum, rhodium, palladium alloy, as we can see from the figure shown on the right side of the video, the gas will be installed in 3 zones. In zone 1, 5 sheets of high content of platinum and rhodium will be installed, and in this zone it will become thinner, and the mass loss from this zone was mainly from the volatilization of platinum to platinum dioxide. In the second zone, 3 sheets of medium content of platinum and rhodium is installed. In this zone, a high content of palladium will present. The palladium will capture the platinum dioxide and form platinum palladium solid solution on the gas surface. The captured platinum will then continue to catalyze and maintain a high rate of oxidation. This will not only reduce the amount of platinum, but it will also increase the platinum utilization. In this zone, it will become thicker as to increase the specific surface area. In the last zone, 5 sheets of catalyst alloy gas is installed. In this zone, it has the highest content of palladium, which can be used to absorb the platinum dioxide and will continue for the catalyzation process. Hence, this improvement will eventually meet the sustainable development element requirements. That's all from me. Let's proceed to the last part of this presentation. Thank you.
For conclusions, we can conclude PTRH-PD alloy group gas catalysts have circulations of catalysis, absorptions, connecting structure, and wire diameter. The catalyst effect improves with PT alloy gas, and as a result, the cost will be reduced and loss PT will be decreased. This result is proved by the research of the journal, which by Lin Chin in 2017. The design will decrease the amount and increase the utilizations of PT in nitric acid industry, and oxidation also can be improved, and the cost also can be cut dramatically. So that's all from our group presentations and explanations about this project. So thank you.